All right, Algebra 2. Today we're going to be doing imaginary numbers and simplifying them out of radicals. So this is one of those things you just have to memorize. The number that we're going to be dealing with is called I. I think you've seen this before, but going on COVID, I'm going to assume you haven't. So there is this number that we work with that can't actually exist in the physical world as a reality, but it can exist in our representation. So what do I mean by that? Like take the letter A, for instance. A we can use to spell apple. We can spell like whatever, asphalt. We can spell a lot of things with the letter A. But A doesn't actually exist in nature. And that's kind of like this number. This number, square root of -1, you can see it right there, the number I, the square root of -1. You're not going to find it anywhere in nature. However, you can use this number to represent some things. This number I is literally used in every single electronic device you own. It's been used in every single sort of like radio processing, signal processing. It's a very important number. So we call it imaginary in the sense that it can't actually, you can't touch it in the real world, but it's a very real concept. It's a very valid idea. And just like the letter A or any letter out there, we can use it to represent complex ideas. So these are technically more than imaginary. They're kind of getting changed to called complex numbers because imaginary makes it seem like they just don't exist at all. And that's not quite true. So with that said, we're going to talk about how this works and what that looks like. So I'm going to go ahead and start. The number I is represented by the square root of -1. If you were to type in onto your calculator right now the square root of -1, you wouldn't be able to basically you wouldn't know anything that was going on. It would just be like junk, nothing's happening, can't do it, all that kind of stuff. And so, anywho, I was trying to get to Desmos real quick. There we go. Desmos. Check it out. So I'm going to do the square root of -1. Undefined, because it's not a real number in the sense that we can see it in the real world. However, it does have some properties to it. So with that said, let's get going. Number 1, we have right here, this is I is the square root of -1. So check it out. I'm going to show you the complex way of why this works, and then I'll show you the other thing. So remember how we've been doing this work where we split it up into 2 different things? So I'm going to show you something. So I can technically split up my -6 into this. So you know how I've been able to pull everything apart? -1 times 6 is in fact -6. I'm going to keep with that same vein and we're going to pull everything apart. It teaches you radicals. I like that better. Whenever you see the square root of I, you can literally replace it with the square root of -1. Or sorry, when you see the square root of -1, you can replace it with I. So check out my next line. That is I times square root of 6. Now, square root of 6 does not simplify anymore, so you end up with I square root of 6. This is technically a little cursive I, but everyone's going to write it the way they want to. The most important part is, remember, it is a lowercase I. If you're giving me some of this, like, okay, there's my imagination number right there, my imaginary number, no, that's a no, dog, not that. We want I, lowercase. So that's it. That's how we can represent that number. Now, what about 2? 2 is a perfect square with that. So I'm going to show you how I start my work. I'm going to once again split up everything. Let me know that you know what's up. Square root of -1, by definition, that you have to memorize, is I. The square root of 81 is 9. So when I put it together, there's no houses here at the very end. So no houses. The I goes at the end. So if there are radicals, it goes in front of the radical. If there is no radicals, it goes behind the numbers and stuff. So that's the basics of that. I'm going to go ahead and do as many of these as I possibly can get done. Square root of 45, let's do it. Using the same technique that I've been teaching you, I'm going to split up everything. I'm going to split up that -1 into its own thing. And then I'm going to split up, can I split up 45 into something that simplifies? Let's see, 15, 3, I don't think so. I think it just stays like that. And if I'm wrong, then somebody can correct me. Let's see, divided by 5. Oh, divided by 9. Yep, it can break down. Duh. Let me do this. 45 can break down in the square root of 9 times the square root of 5. Square root of -1 breaks down to I. Square root of 9 breaks down to 3. And the square root of 5 does not break down at all. So that leaves us 3I square root of 5. Notice the order. Number, I, and then the radicals. Let's do number 4 together. I'm going to break it apart in one fell swoop. -1 times 9 times 8. And pay attention to the fact that with multiplication, I can pull apart my radical houses. So -1 I pulled out. 9 times 8 is 72. For anyone wondering where I got that, 9 times 8 is 72. And, oh, this isn't even the best one. I'm going to do this again. Okay, I'll do it one more time. Watch how I'm going. This is not the best number to pick, but just keep watching because I see some of y'all make this mistake on the quizzes. I'm going to replace my -1 with an I. I'm going to replace my square root of 9 with a 3. And then, my 8 can actually break down a little bit more. I'm going to break it down to here. That's the best part about this method. If you make it in quotations a mistake, that you don't pick the biggest number, you can still always do it on the next line. So I times 3 times square root of 2 is 2, and then square root of 2 does not simplify. So we have our house with the 2 inside. We have an I, and then 3 times 2 is 6. So check right there, push pause if you're lost on where I got that. And try it again. The other way you could have solved number 4 over here is if you split it up into -1 times the square root of 36 times the square root of 2, because 36 times 2 is also 72. So pseudo mistake, but learning experience. Going to the next one. 5, again, I wish y'all would watch my videos because it shows you over and over the same method, split everything apart. This is my MO. I like to split everything apart and then evaluate as I go. There's my -1 I pulled out. 3 can't evaluate. The square root of -1 is I. And then I can break up my 20 into 4 times 5. So, and now what I'm going to do is I am going to do the next line, kind of like a little robot. Feels like a factory doing this type of work. And that's that. So now I'm going to put everything together. I have a house with a 5 in it. 2 times 3 is 6, and there's that I. Boom, boom. Going on to number 6, I'm going to split that apart. 4 is right there, times the square root of 6 times the square root of 4. I'm going to write everything out. My square root of 6 does not simplify, but my square root of 4 does, and it simplifies down to 2. Now I'm going to draw. Everything is simplified down. My 6 stays inside the house, and I have a 2 and a 4 outside, which when multiplied goes like that. All right, let's go to number 7. Rules. The rules for exponents, y'all. With the negative ones, not the negatives, the odd ones, you split it apart like this. Subtract 1 from that 3, and then split it apart. And you will notice the 2 plus 1 is equal to 3. That's how exponents work in multiplication. Even rules, divide by 2, drop the house. Divide by 2, drop the house. So 2 divided by 2 is 1. And then I am left with the square root of x to the 1, which does not simplify at all. And then to make it pretty, I want to get rid of all those extra 1s that we don't need to look at. And there we have it. Number 8. I'm going to once again separate everything out. That's the way I like to roll. Times the square root of x to the 6th. So I have my -1 pulled out, and now I can evaluate these. The square root of -1 is in fact I. And then the square root of x to the 6th, the rules of evens. Take that even number, divide by 2, and erase the house. So 6 divided by 2 is 3. And I'm going to write that down. Boom. And now I have I x to the 3rd for my answer. I'm going to go to the next one. Number 9. Here we go. Check out this. This is going to be fun. You just break it apart one thing at a time. So we have -1 that I'm going to break apart. I have my 12 I'm going to break apart. And then I have my x squared I'm going to break apart. So this the square root of -1 is I. Mister, I don't understand that number. I don't get it. Y'all, accept it. This is the new lesson. Accept that someone smarter than all of us came along and said the square root of -1, we're going to represent as I. Just accept it. 12, I can split apart into 4 times 3. So I'm going to split that sucker into 4 times 3. And then my x squared square root, I'm going to go ahead and evaluate. That's an even number. So I divide by 1 or 2, and I drop the house, which leaves me with that. All right, next line of factoring this garbage. Square root of 4 is 2, and then the square root of 3 does not change, and then x to the 1, I'm just going to rewrite without that 1 there. So now I can't simplify anything. Now I reconstruct this. My 3 goes inside. I have an x that's out here. Let's see, I have a 2 and an x and an I. So here we go. 2ix. If you wrote 2xi, I would accept that as well too. But since we prefer the, what's it called? I next to the numbers, but it's, it's formality at this point. So either of those are fine, but try to get used to putting your I's next to your numbers. It just looks prettier. Number 10. Oh my God, it's so much. I don't know what to do. Literally the exact same thing. You're going to do the exact same thing. Break everything apart into separate small problems. That's it. Oh God, it's so much. Deal with it. No one cares that you don't like doing math. Just deal. So here we go. Look at that. I split everything apart on one thing. Good to go. Let's evaluate. 2 doesn't simplify. Square root of negative 1 simplifies down to I. The square root of 40 actually can break apart into, let's see, I believe 4 times 10 is what we're looking for. And then the square root of x squared. Remember the rule, it's an even exponent. So 2 divided by 2 is 1. So divide by 2 and erase the house. And then this thing right here, I got to split that sucker up into separate pieces. Square root of y to the 1. All right, one more line of this. We're machines at this point. Square root of 4 is 2. Square root of 10 does not simplify. That x to the 1, I'm going to go ahead and write as just x. Remember the rule, y squared, 2 divided by 2 is 1. Erase the house, leaving us with just y. And then I cannot simplify the square root of y to the 1. That is as simple as it gets. So I'm going to erase that 1 and just have it here. Now check all my terms. Are these as simplified as they get? The answer is yes. And we're going to go through. What's inside the house? At this point, we have 10. That's good. We have y. That's good. And now what's outside the house? Let's see, I have a y and an x outside. So let's get rid of that. And then I have an I outside of that. Let's get rid of that. And then I have a 2 times 2, which is a 4. Now, you'll notice I did none of this in my head. I literally solved this one step at a time the exact same way. So when I came up to number 10 and it looked big, it's the exact same process, y'all. I believe that's the last example, and that's it. All right. There's a Delta Math assignment.